In the present video, we will discuss the line balancing problem, which is given in the July 2021 for the mechanical from the JNTU Hyderabad. Let's see the problem. An assembly line consists of 4 workstations. Each workstation performs a designated work for which the work contents are as under. So here it is given the 4 workstations along with the time required for the piece. Then we have to determine the A, what is the cycle time, B, calculate delay for each station, C, calculate line efficiency, D, how many units will be made in a day of 8 hours work, which includes a total of 1 hour break for lunch and tea. So let's see the solution. First we have to determine the what is the cycle time. We know that cycle time is the maximum workstation time. So here it is given the different stations along with the time required it is given. So cycle time equal to the maximum time of the each workstation time. So maximum of 4, 2, 2 and 2.5. Among these all the times, maximum time is the 4 minutes. So cycle time equal to the 4 minutes. Next we will determine the delay for each station. We know that ideal time or the delay at each station which is equal to the cycle time minus work content. We know that when the cycle time is the 4 minutes for the each station, then we have to determine the delay for the each workstation. So let's calculate the first station. So for the station 1, work contents is the 4 minutes and we know the cycle time is the 4. Then delay in the first workstation is the 4 cycle time minus work content time is the 4. Then delay time in the first station is the 0. Similarly, the second workstation cycle time is the 4 and work content is the 2. Then delay time is the 2 minutes. For the third station, cycle time is the 4 and work content is the 2. So delay time is the 2 minutes. Similarly, for the fourth station, cycle time is the 4 and work content is the 2.5. Then delay is the 1.5 minute. Next question is calculate line efficiency. We know line efficiency equal to sum of task times divided by actual number of workstations into workstation cycle time, and sum of task times which is equal to the summation of total time of the each workstation. Then sum of task times will become the 4 plus 2 plus 2 plus 2.5, which is equal to the 10.5 minutes. And number of workstations, so here it is given the number of workstations are the 4 and cycle time also it is the 4. Then line efficiency equal to the 10.5 divided by 4 into 4 which is equal to the 16. Then line efficiency equal to the 65.62%. Let's see the next question. How many units will be made in a day of 8 hours work, which includes a total of 1 hour break for both lunch and tea? So here I have to determine the number of units. We know the cycle time formula, that is the total availability time divided by required output or number of units. Then from this equation we can be written as number of units equal to total available time divided by cycle time. So we know cycle time is the 4 minutes. Then we have to calculate the total availability time. So here it is given the working time is the 8 hours. But and also it is given the break for the lunch and tea is the 1 hour. Then total availability time equal to the working time minus break time, which is equal to the 8 hours minus 1 hour, that is the 7 hours. But here cycle time is given in the minutes, so total availability time also have to convert into the minutes. Then 7 into 60, which is equal to the 420 minutes. Now we know the total availability time is the 420 and cycle time is the 4. Then number of units equal to the 420 divided by 4, which is equal to the 105 units per day. So number of units equal to the 105 per day. So for the given problem, so what is the cycle time? So cycle time we determine that one the 4 minutes, and delay time for the east station is the first station 0, second station 2, third station 2, and the fourth station is the 1.5 minutes. And next question is the line efficiency. Line efficiency equal to the 65.62%, and the number of units equal to the 105 per day. So this is the solution, and thank you.